Hey, good morning, everybody. Had a question on the Delta Math assignment, and I really like this assignment, and so I don't want you to get so frustrated that you're just really unhappy. I mean, if you have to be a little bit frustrated because that's a sign that you're growing, but at a certain point, we just need to stop because I don't want you to be laboring and banging your head against these assignments for so long that you're just an unhappy person. So I'm not sure what the time frame is when you work on an assignment. Maybe a half an hour at a time, or maybe an hour. No more than an hour. Maybe a half an hour is a good time to just stop and then reach out for some help. So I'm gonna go over some of these. Let's see how they go. There were three sets of questions for this assignment, and this is the first set. For which values of x is this undefined? And almost always this is going to be division by zero. So there's only one number that makes us divide by zero, and that is -9, because -9 plus 9 is zero. Let's try another one. Here is -7, because when x is -7, -7 plus 7 is zero. Let's see if they give us a different one. Okay, so now here you might have to factor a little bit, I guess. Let's see here if I can. You could take out the 3, and you're left with x plus 4. If you could do that in your head, that's fantastic. And so what do I discover? I discover that when x is -4, it is undefined, because -4 would make you divide by 0. Here, okay, is there an eraser? Here we go. This might be the last one. First of all, even if the numerator and if the certain factor that you're looking at happens to cancel out, that is still a point of discontinuity. That would still be an x value that would make it undefined. Any x value that makes you divide by 0. So here, 2x minus 5. So what x value will make that 0? Well, I would, let's see here. I don't know. So I use algebra. Algebra serves us. So I say, let's set 2x minus 5 equal to 0 and solve for x, and then that'll help us discover what it is. So I would have to add 5 on both sides and then divide by 2. So the correct answer is 5 halves. Positive 5 halves would make me divide by 0. All right, let's go to the second set of problems. Determine each feature of the graph of the given function. So, all right, this is great. I love this problem. So you have a rational function, and it's asking for the horizontal asymptote. It's possible that there is no horizontal asymptote. This one does have one because the degrees are the same. It's first degree compared to first degree. So in that situation, you always divide the leading coefficients. So -1 divided by +4 is -1/4. So that is the horizontal asymptote. Now the vertical asymptotes, well, let's see here. If I take out a 4 from the denominator, I'm left with x plus 3. And I have to be careful here because the numerator, it doesn't quite look like x plus 3, but it looks kind of close. In fact, it's the exact opposite of x plus 3. If you factor out a -1, you would be left with +1x plus 3. So what does that tell us? Well, that tells us that there is no vertical asymptote because the one thing that makes you divide by 0, -3, that one thing, that happens to be a hole, a removable point of discontinuity. So x equals -3 is a hole, and that will go right here, -3. And what is the y value when x is -3? Well, first of all, when x is -3, right here with this purple, there's no solution. There's no number. It's undefined because you're dividing by 0. So you'd have to cancel out the x plus 3's first. And when you do cancel out the x plus 3's, what are you left with? You're left with -1/4. So when x, so this doesn't depend on x at all. There are no x's here. The answer is just -3 for the x value, -1/4 for the y value. That is the whole. And since when you canceled out this factor, there was no other possibility of division by 0. You're just dividing by 4, so that's why there are no vertical asymptotes. The x-intercept in rational functions is the x value that makes the numerator 0. Well, first it's not -3, because remember, -3 was the whole. So after you remove that factor, the numerator is just -1. So -1 will never be 0. There's no x value there. It's not -1 times x. It's just -1. So there is no x-intercept. The y-intercept is when x equals 0. So if you type in 0 for x, these two cancel out, and you're just left with -3/12, which is again -1/4. So that is the okay, so this one I do want to spend a little bit more time on. This is a rational function, but knowing that the x plus 3's cancel out, you're just left with -1/4. What does that graph look like? It would just look like the line y equals -1/4, the flat line. And you would have, let's see here, y equals -x minus 3. Hold on a second. What was the denominator? 3x plus 12, I think. And the numerator was -x and then minus 3. No, that couldn't have been it. 4x plus 12. Oh, yeah. I should have thought that one through. All right. Now there's a flat line. Hopefully this is not, this should be informative for us. If it's not a surprise, that's great. But this is a rational function for sure, but we now know that x plus 3 is a common factor that would cancel out. So when it cancels out, all you're left with is y equals -1/4, which is just this flat line. And remember, -3 was the problem? Well, there's a hole right at -3, if I can land on it. There is a hole at -3. So this function is just the flat line y equals -1/4 with a hole at -3. Let's try another one. Okay, this one. I'm going to pause the next time I do that so you don't have to see me do that nonsense. Horizontal asymptote. Again, the degrees are the same. First degree, so you divide the leading coefficients, -2/3. Horizontal asymptote. Vertical asymptote. Well, let's not be too hasty here. Let's factor. The top factors, I take out a 2, you're left with x minus 4. The denominator doesn't even factor. It's his prime, because there's no GCF besides 1. And so you can't move on. Well, that means that there is a vertical asymptote, because this factor -3x minus 4 does not cancel out with x minus 4. So it is a vertical asymptote. So what x value makes this 0? So I would imagine adding 4 to both sides, set the bottom to 0, add 4, divide by -3. I would get -4/3 is the vertical asymptote. A hole is the x value that makes the numerator 0, and there is one. 4. Oh, sorry, did I say hole? I meant x-intercept. I don't know. An x-intercept is the x value that makes the numerator 0. And in this case, it's 4. The y-intercept is when x equals 0. It doesn't matter. You could plug it into the purple one or the black one. The black one would be easier. If x is 0, then these two go away, and I'm just left with -8 divided by -4, and that's +2. And there is no hole. There is only one point of discontinuity. And if there's only one point of discontinuity, it's either a vertical asymptote or a hole. It can't be both. And in this case, it's a vertical asymptote. I submit my answer. And let's do another one of these. Oh, this is a good one to do. All right. Excuse me. Here, this is a great one to do. We have, first of all, the horizontal asymptote. Again, the degrees are the same. X squared versus a squared. So again, you divide by the leading coefficients. -1 divided by 2, -1/2. Vertical asymptote, x-intercept. Let's factor to investigate. The numerator I can take out an x, and I'm left with the opposite of x plus 5. The denominator does not factor, really. I mean, I could factor into those little, well, I don't know what they're called. So here, what do I get? I see that these two x's cancel out. But when they cancel out, I'm left with, what am I left with? The numerator is negative x plus 5. The denominator is just 2x. So what the point of discontinuity, there's only one number that would make you divide by 0. One number, and that number is 0. 2 times 0 squared is 0, so 0 is the problem. But now, 0 cannot be a whole and a vertical asymptote at the same time. It cancels out, so we think it's a whole, but then it's left over, so it's a vertical asymptote. It can't be both. What we end up with is the deciding factor. We end up with a division by x. Right here, we might be thinking it's a whole because it cancels out, but when we look at what we are left with, we're still dividing by 0. So canceling out that x didn't keep us from dividing by 0 still. The number 0 still is a problem. So that means it is a vertical asymptote. It is not a whole. There is no whole here. Even though the 0 cancels out, if you try to find, you'd be in trouble if you tried to find the whole, because if you tried to plug in 0 into here, you would have 0 plus 5 divided by 0, and you really couldn't proceed. So that would be a help to us, to help us to realize that there just cannot be a whole at 0. Even though it cancels out, the number 0 was still a problem. It was still a division by 0, so it is a vertical asymptote. Okay, is there an x-intercept? Is there an x value that makes the numerator 0? Yeah, 5. If x is 5, the top is 0. The bottom is 10, but the top is 0, which makes the whole thing 0. Is there a y-intercept? Well, that happens when x is 0, and remember, x can't be 0 because you're dividing by 0. And there's a vertical asymptote shooting right through the y-axis, so there is no y-intercept. And so this is our final answer. Let's do another one. Oh, here's a good one. All right, this will be the last one in this section. So now I have, for the first time, the two degrees are not the same. The degree in the denominator is larger than the degree in the numerator. So that means there is a horizontal asymptote, but it occurs when y is 0. The rest we're going to have to factor. So the numerator has a GCF of 2, so I take that out. The denominator is tricky. You got x squared and 4. Those are 2 squares. And please, please, please listen to me now. If you see 2 squares, you have to be very sensitive to a difference of squares. Difference of squares are very, very popular in math classes. Every math class you take for the next 10 years, you're going to have difference of squares in there, and you're just going to be a happier student if you can recognize that. X squared is a square, 4 is a squared. And you may think, oh, well, it's a sum of squares. You're not minusing, but there is a negative right here. So we can factor out a negative 1. That would make it positive 1x squared minus 4. And voila, you have now a difference of squares in the denominator. The top is 2 times x plus 2. And the bottom, the denominator factors into x plus 2, x minus 2. These x plus 2's cancel out, and so I'm left with this. Okay. Well, since this canceled out, that tells me that there is a whole at x equals negative 2. What's the y value? Well, you have to plug in negative 2 to find it. You can't plug in negative 2 into here because you would divide by 0. Nor can you plug it into here because you would divide by 0. So you have to plug in negative 2 into here. And after everything's been canceled. So when you plug in negative 2 minus 2 is negative 4, right? but then there's a negative out there. So a negative 1 times a negative 4 is a positive 4, and 2 divided by positive 4 is a half. So that's where the hole is, negative 2 comma a half. The vertical asymptote is an x value that makes you divide by 0 that didn't cancel out. And in this case, when x is 2, you're dividing by 0, and that did not cancel out. So that is a vertical asymptote. X-intercept is any x value that makes the numerator 0. And it looks like negative 2 makes the numerator 0, but remember, negative 2 was the whole, so it can't be that. The numerator is now just the number 2, and there's no x value that's going to make 2 0. 2 is just 2. That's why they call it a constant. It doesn't vary. Y-intercept, when x is 0, you could plug in 0. 0 is a safe number. 0 doesn't make you divide by 0 in this function, so you could plug in x equals 0 into any one of these expressions. And I'll just do the first one. When x is 0, these two terms disappear, and I'm left with 4 divided by 4, which is 1. And that is all we were asked to do. All right. Here is the third set of problems from your homework, and this is asking you to graph. All right, and it's still asking you the same 5 things. So, okay, so it's a similar situation here. We have to factor. All right, the numerator. Let's actually start with the denominator. I'm starting with a negative right there. Let me look at the denominator first. They both have a 4 in common, so I can take out a 4, and I'm left with x minus 5. The numerator definitely has an x in common, but I see the 2 and the 10. If I take out that 2, I'll have a 5 right here, which is probably going to match up with this factor. So I'm going to take out a negative 2x from both terms. The first term, I would just be left with x. The second term, positive 10x divided by negative 2, is negative 5. Now, what are all the common factors that cancel out here, guys? Well, there are 2 of them. The x minus 5s cancel out. That tells you there's a hole at 5. And then 2 and 4 both had a 2 in common, so they cancel out, leaving me with negative 1x in the numerator and just 2 in the denominator. Whew. All right, what does that mean? Well, it means that there is no vertical asymptote. There's only one number that maybe divide by 0, 5. And that 5 happened to cancel out. So that means it's a hole. But where is that hole? Let's see here. When x is 5, the original function is divided by 0. But after I cancel it out, if I type in 5 into here, I would get the y value of negative 5 halves, which is negative 2.5. So now I can plot this hole carefully. So I need to plot 5, negative 2.5. So about right there. The x value is 5. The y value is negative 2.5. All right. Is there a y-intercept? If I plug in 0 for x, what will I get? Well, if you plug in 0 to x into the original, these two become 0, and the bottom becomes negative 20. Well, what's 0 divided by negative 20? It is 0, right? So there is a y-intercept, 0, 0. I almost said negative 20, but when x is 0, this whole function equals 0. Even over here, when x is 0, 0 divided by 2 is 0. X-intercept. Is there an x-intercept? Yeah, there is a number that makes the numerator 0. There were actually 2, 0 and 5, but 5 was the whole. So there's only one x value remaining that makes the numerator 0, and that is the number 0. But that was already plotted because the x-intercept is actually the same as the y-intercept. Horizontal asymptote? No, because the numerator's degree is larger than the denominator's degree. So there's no horizontal asymptote, there's no vertical asymptote. I've graphed the only 3 things that I can graph. So now I just press plot rational function, and there it is. And it's a line. It's a line, negative 1/2 x plus 0, which is exactly what this is saying. It may not look like that, but it is. This right here is the same thing as negative 1/2 x plus 0 in mx plus b form. Okay, here's a second problem, and right away I notice that the degrees are the same, so that means that there is a horizontal asymptote, and it occurs when I divide the two leading coefficients. Well, negative 3 divided by negative 2 is negative 3/2, which is negative 1/2. So I have to drag it down to where y equals negative 1/2. All right. The asymptotes are very important because they help guide where the function is going to go. When I graph my function, it may pass through this asymptote. That's not a big deal. But what will happen is when x gets big, so when I go to the right, and when x gets small, when I go to the left, the graph will be approaching this line. That's the definition of an asymptote. The function will approach the asymptote. I can also do the y-intercept right now, because when x is 0, the top is just negative 36. The bottom would be, the bottom would be 0. So when x is 0, I'm dividing by 0. So that means there is no y-intercept. The rest I'll have to factor here. So the numerator, those are some big numbers, but fortunately I can look for a GCF, and there is a GCF. I'll take out a negative 3. That will get rid of all these negatives. And when I do that, let me pause the video. I get this. And this will also be factored further. I'll have to find two numbers that multiply to 12 and add to 7, which I can do. That's 4 and 3. The denominator also has a GCF of 2x, so I'll factor that out. Okay, so everything is factored, and right away there's lots of good starting points, but realize in the denominator there are two x values that make you divide by 0, negative 3 and 0. So that means there are 2 points of discontinuity. Now, since it's not a piecewise function, those 2 points of discontinuity either have to be a vertical asymptote or a hole. And there is a hole at x equals negative 3. The other one, 0, doesn't cancel out, so that is a vertical asymptote. So you're left with this ratio. After you cancel out these x plus 3s, I'm going to find the hole first, the removable point. And this is my remaining function. I know there's a hole when x equals negative 3. What's the y value? Well, I plug in x equals negative 3 into here. And now we can do this in our heads, because first of all, negative 3 plus 4 is just 1. So the top is negative 3 times 1. But this negative 3 cancels out with this negative 3. This is negative 3 times 1. So negative 3 is a factor. And this is 2 times negative 3. So the negative 3 is being connected by times, which means it's a factor. So that cancels out. The top is just 1. The bottom is 2. So there is a hole at negative 3, comma, 1/2. 1 over 2. So negative 3, comma, 1/2. Right there. Oh. Okay, so vertical asymptote. Yes, 0 is a vertical asymptote, because when x is 0, you're dividing by 0. So, and since it didn't cancel out, it is a vertical asymptote. So I click on vertical asymptote, and now I got to drag this over here to when x equals 0. Y-intercept? No, because for a y-intercept, x has to equal 0, and that would make me divide by 0. So there is no y-intercept. Is there an x-intercept? Is there an x value that makes the numerator 0? Yes. Negative 4 makes the numerator 0. So I click on x-intercept, a little x-intercept pops up, and I drag it all the way to negative 4, comma 0. And I'm about to plot the graph here, but look at my two asymptotes. They guide my function. I know my graph is going through this point, and it will kind of hop over this hole. So you can see, I hope you can see in your head, it's going to curve like this. And the other side, it usually mirrors through like the new cross section here. But we just press plot function and it does it for us. Let's try to do another one of these. All right, here is another one. This will be the last one. First of all, well, there's a lot. I have a difference of squares here. I don't know what to say first. There's lots of information here. Difference of squares. Hopefully, I hope you recognize those. I first see that the degree of the denominator is 2, the degree of the numerator is 1. So that means there is a horizontal asymptote at y equals 0. If the bottom degree is bigger, y equals 0 is the horizontal asymptote. And I can plot the y-intercept right now because if I let x equals 0, all I'll be left with is negative 12 over negative 16. What does that equal? Well, the negatives cancel out, so it's just 12 over 16. They both have a 4 in common, so when I cancel out that 4, I'm left with 3/4. So the y-intercept is 0, 3/4. And the x-intercept, is there an x value that makes the numerator 0? Yeah, 4. If x is 4, that's 12 minus 12, that's 0. But if x is 4, the bottom is 16 minus 16, and that's 0. So there is no x-intercept. We need to factor this. And here it is factored. The numerator had a GCF of 3. The bottom was a difference of squares. And I see, of course, that the x minus 4's cancel out. What does that tell you? There is a hole at x equals 4. But also, negative 4 is a problem. Negative 4 makes me divide by 0. Since that didn't cancel out, that is a vertical asymptote at negative 4. So let's just get that out of the way. Bam. All right, now I have to find the removable point. There is no x-intercept. We already talked about that, but there is a hole when x is negative 4. So I have to plug in negative 4 into 3. Well, I'm sorry. There's a hole at positive 4, because that's the thing that canceled out. So I have to plug in positive 4 into 3 divided by x plus 4. Well, we can do that in our heads, right? If I plug in positive 4 into 3 divided by this becomes 8, and this is 3, so that's 3/8. So there is a hole at positive when x is 4, because that's the thing that canceled out, and the y value is 3/8, so less than a half. And here is everything that I'm required to graph for this problem. I got 2 asymptotes, and my graph is going to slide through this y-intercept, hop over this hole, and there it is. Hopefully that was beneficial, and I hope it helps.